asynchronous programming, give you a quick overview and with some demos to describe the differences. Good. Any questions? Please, guys, feel free to stop me. Okay. So my first question to you guys, first of all, do you know the difference between synchronous and asynchronous? That's my start. Okay, do you know? Okay, cool. Have you developed asynchronous programming before? Not using the async and await? So just for those who doesn't know, I mean, like asynchronous programming is painful, honestly. I mean, from a coding perspective, like if you're so first of all, the difference between synchronous and asynchronous, synchronous programming, which means like the code is kind of one thread, moving all. Okay, let me. So it's like the whole code is on one UI. You know, it's kind of a step after the other. You know, you can do something in the background or whatever. Asynchronous programming is kind of a parallel kind of task parallel threading or something. You're doing like some sort of thread. So for the asynchronous programming, if you were planning to develop an application using asynchronous programming the normal way, if you've ever thought about developing that, really the code is really painful to do. I mean, like tracking the code, and if you have a bug or whatever, it's not an easy thing to do. So we came up with async and await. So so you know, you can avoid. Okay, sorry. So for asynchronous programming, I mean, you can avoid there is a performance bottlenecks, and I mean you can avoid the performance bottlenecks and enhance the overall responsiveness of your application by using asynchronous programming. Okay, which is traditional, but as I said, like traditional techniques for writing asynchronous applications, like they're very complex and really painful to write, debug, and maintain, and what have you. In Visual Studio 2012, we introduced a simplified approach, which is the async programming that leverages the asynchronous support for the .NET Framework 4.5 and the Windows runtime. The compiler does the difficult work that the developer used to do. So there's a lot of code happening, a lot of tasks happening in the background that the developer is not longer asked to do, and your application returns a logical structure that resembles the synchronous code. So it will look like a synchronous code, however, it will be doing the thing asynchronously with a fraction of effort. So let me just tell you a story before getting started with the slides. So let me hide the slides and. I think you can hide the slides somewhere. Okay, hide slide. Okay. So before I get started with the slides, so again, let me summarize the importance of asynchronous programming in a real life scenario. So imagine you guys, I mean, like I can guess, like most of you guys went to a pizza store, right, or a pizza market or whatever, a restaurant. What you can what we normally do is when you go to a pizza restaurant and go to, for example, to buy pizza, so you go to the restaurant, you go to the cashier, and I'm talking here about a takeaway, okay, and you order a pizza, and then you pay the cashier, and then there's a queue of people behind you. So what do you think is going to happen after you pay the cashier and you order your pizza? Okay, I'm going to get this pizza. I'm going to pay like $100 for this pizza, and then I'm done. I got my receipt. What's going to happen next? I'm asking a question, by the way. I mean, like, wait for order. Yes, I mean, like, yeah, you wait for the order, but what happens is the guy will eat it. Okay, thanks, Cindy. That was yeah. There's a queue line. Thanks, Robert. What happened is the cashier in a real-time scenario, the cashier would just tell you, please wait in this waiting list. I mean, waiting queue or whatever. Like, go on that side, and then I will get you back when the pizza is ready, so that he serves the other one. That is asynchronous programming. You know what happened? even if that restaurant is just having one man show, it's a one man show restaurant. The guy takes the thing from you, he throws the pizza inside the oven, and then I mean, like in a synchronous programming way, the guy will have to wait. The guys waiting for you in the queue, behind you in the queue, will have to wait for your pizza to be done, and then he gets that pizza, and after you have the pizza, and the guy will wait for like 30 minutes, then he can order his pizza, which is not quite practical. But what happens is you'll move aside, and then the next one will be the next one will be served. So this is what exactly happens. So, however, if you go to this pizza place again, or the next guy in the queue, so now you've been put aside, right? And then the next guy comes, and he does not want to order a pizza, and he wants to order a bottle of water, for example, or a can of soda. What's going to happen is the guy won't, he will pay, he's going to get his receipt, but what will happen is the guy is not going to put him aside, right? He'll just wait, and then he'll get him the water, and then the guy would leave. Why is that? Because the time that the user the guy in the queue is required the service to be is very small. So that's why the cashier or the main guy in the of the pizza restaurant will serve him instantaneously. However, if he will take more time, a lot of time, then he will have to wait, and he'll put him on the side so that he understands, and so that he gets he gets served once the pizza is done. That is asynchronous programming, exactly. So for asynchronous programming, I'm not sure if you guys got the pizza thing. I mean, do you need any? I mean, like really? I mean, like if you understand this, everything else is going to be fine. If not, then let me repeat it. Okay, you want me to repeat? I'll be more than happy. Okay, I'll take that as understandable. Okay, so for Windows Phone 7.1, questions? I got it, but the pizza's part is distracting. Okay, let's see till we finish up the thing, and if you have a question, let me know, and then we can repeat. So so the Windows Phone 7.1 base class libraries, in the .NET 4.0 patterns, it supported asynchronous programming. However, the async programming model being used at the begin and the end methods. Like example, we can use that in HTTP web request begin get response and end get response if you're familiar with web services. So the event asynchronous, it's what we used to use in 7.1. I don't want to talk about that one. It's still working in Windows Phone 8, but now in Windows Phone 8, any API that potentially which includes many WinRT APIs, any API that potentially takes more than 50 milliseconds to complete is exposed as an asynchronous method using a new pattern called task programming model, or a TPM. Okay, so what I want to say here is, like, if you go back to our pizza example that got a lot of you confused, like if you are ordering the bottle of water, it's taking like less than 50 milliseconds, or 50 milliseconds or less, then it's not going to be an asynchronous thing for you. But if you're ordering a pizza which is going to take more than that threshold of 50 milliseconds, then an asynchronous method should be used so that you don't stop the queue, and then the application should be, or the restaurant should be still working and accepting new orders and new requests. So this is what sums it up for us. Asynchronous programming is a first-class citizen of the WinRT, that is which is WinRT, which is the backbone for Windows 8, used for file I/O, networking, things that really consume lots of the thread and resources of your application. It is the way to write asynchronous code. And many of the new APIs in Windows Phone 8 and the future will offer only task-based APIs. So that's, again, so to wrap it up, any API that potentially takes more than 50 milliseconds to complete is exposed as an asynchronous method using a new pattern called task programming model. If not, then you can just go with that as it won't hurt the UI. So let's take an example in our code instead of the pizza, and let's see how things would look like. this is, this is the how, you store values in a file, all right? Or this is how you open a file, read from the file, and then close the file. You start an object, okay, and this is the time needed. This is the UI thread, which is the main thread of your application. This is here. So you start an object of, called ISF. You're getting the user store for application. We're going to cover that in the file and storage session. And then you're opening the file stream, and then you're opening the file called captainslog.store, opening that file. Opening the file can take time, so the UI thread would be blocked, which means that no request, nothing in the application will be processed, everything in the application will stop till this file opens. Once it's opened, you can do a lot of other stuff. And then once it's open, then stream reader, you can read the file, read it till the end, and then you need to close the file, right? And to close the file, that also takes time. So the application will hang. Really, that's what happened. The application will hang. You will not be able to do anything in your application till you close the file. So from a user experience perspective, that's against the UI fast and fluid. Taking a look at using synchronous programming, you can open the file, move it to another thread, and at least from a UI thread perspective, the main UI of your application will continue to be the same. I mean, it will never be blocked. You can open files or read files or close files in your application and still be able to do things like, I don't know, checking something, navigating to another page, doing whatever. Like I used to do this. You can download something in the background. So if you're using that in an asynchronous programming way, or putting that on another thread, that's what is happening in a fast and fluid way in Windows Phone 8. So taking exactly like making it a breakdown. So if you specify that a method is an asynchronous method, you just add a word asynchronous in front of at the beginning as an async method by using an async modifier. You enable the following two capabilities, okay, which are the marked async method can use await. This is the await, which means that await here is to create or to designate something called suspension points. Guys, am I talking gibberish or are you following? We're following. No, so far good. I'm happy. Yep, I love you guys, really. Yep. Yes. So Zarina is asking. So asynchronous programming means running tasks on the background while other also activated. Yeah, more or less. That's yes. Not while others. Yeah, I mean while the main UI thread is available to do other tasks. Yep. So let me continue and then take the questions at the end. So again, so we've got the await. What does this await mean? Okay, the await means that we are designating something called suspension point. Okay, the await operator tells the compiler. So when you add an await here, you're telling the compiler during the compilation time, we're telling the compiler that the async method cannot continue past that point. Okay, can you please go on mute? Because let me check. Okay, thank you. So guys, if you are not on mute, can you please go on mute? Okay, just put you guys. Oh, thanks. Okay. Oh, it's the attendees. And mute. I think there was a mute all button for that. Okay, yep. Now there's no echo. So again, so await the await operator that we're using here, it tells the compiler that the asynchronous method that we're having here cannot continue past the point that we're at, the point that we're stopping at here, which is opening the file that we want to open, that captions log.store. This is a file we want that we're creating that object, and so that we open, we're getting that file, so that we open that file. So we tell the compiler that the asynchronous method cannot continue past that point until the awaited asynchronous process is complete, which means the file is open. So it moves this task to another thread. We've got a thread pool to another thread. It opens the file, and once the file is opened, it returns back to that await. You can now create a read streamer, and you can open a stream reader to read from this file that you created, from the storage file that you created. And then this one is containing another await. So instead of blocking the UI thread, the main thread we're having, you're moving that to another thread, and the main thread is available to do other tasks. And then till the reader reads till the end or whatever, or open this in this example, it will open the stream reader, it will move to the other thing, and then it returns back, and so forth. This is how exactly what happens. This is what await tells the compiler. So the suspension of an async method at an await expression does not constitute an exit from the method. Okay, we're not exiting the method. Okay, and so and the finally blocks don't run. So we're not exiting any methods here. The marked async method can itself be awaited by a method that call it. So you can make an async and await, and async and await, and you can do that. So an async method typically contains one or more occurrences of an await operator, as you can see in the example here. But the absence of await expression does not cause a compiler error, by the way. So if you don't have an await, that's okay. And we'll talk about when you can use await and when you cannot use await for asynchronous methods. Okay, we have a question. Okay. Question. What happens when multitasking? Wow. What happens when multitasking? The application can go into another method while it's still stuck on the await line? Can the application go into another method while it's still? That's again what we're saying. The await tells the compiler you cannot continue beyond that. You can make an await till this other method is done, and then you can make an await to the method that you want to run, so that you cannot so that if another method is done and it needs an input from this method, it won't execute unless it gets the value. And for handling exceptions, and that I'll show you in a few slides how you can do that in a very easy way. Okay, best scenario, assume you want to stream some audio in your app, but you want to continue performing other tasks with your app. I think I will enable you to do that without waiting for the streaming to complete, then continue. What are the chances of arriving at deadlock? Will the app hang? Let's see. I'll show you right away. Okay, where did we stop? I think we stopped here. So guys, can we leave the questions till after the demo, because we're running out of time, and I think the demo will show you a lot. But I just want to get done with the theoretical part and then show you the demo and how that works in a real-time scenario, and you'll find it a very, very interesting thing to do and to use in your applications. So I think that was a question for someone was asking. So using these enhancements, mere mortals can write asynchronous methods almost as easily as writing synchronous methods. No more callbacks. If you wrote synchronous, if you used to do callbacks, you don't need to do that. No more explicit marshalling of code from one synchronization context to another, and you need to worry about the flowing of results or exceptions and all of these things and workarounds and tricks that to existing language feature to ease the async development. In short, it really makes everything very very easy for you. So if you guys if that's the first time for you to work with asynchronous programming, you might find that like it's easy. But if you have already worked with asynchronous programming before and not used the async and await, you will definitely feel the beauty of this and how that would make it easy for you. So instead of writing a code that wait for that and then and then putting that in a method and then the return value you can then run after this thing is done, you can run another method and what have you. You can just use the string and the wait. And for the question I got, I think about using the sync and await and what if a method is waiting for the other one. As you can see here, here's a sync void some method like this method, and now it's awaiting the execution of this method, right? So that's an async calling an await, and when this await is calling another synchronous method. So it's kind of a nested one. So all async methods must return void, okay, or task of a template result, like a task of a string, task of integer, task of float, whatever you want. So you can't just so that this is very important. You can't just make like a sync string or a string. This is because all of these are tasks. So you're sending a task. Caller can use the await keyword to code the async operation to be executed. So this is a kind of a wrap up. So caller can use the async keyword to code the async operation to be executed on a thread pool thread and completion awaited. When the async code is complete, it calls back. It makes the calls back automatically and resumes where it left off, which is assigning the value to the data and then passing the value to the return. Returning the value to the data and then passing that to the text box. So it automatically marshals back to the originating context, so no need to use the dispatcher to set the UI object on the UI thread. And all method that contains calls to awaitables. So if you add any awaitables here, you need to use the async. If you don't, the compiler the IntelliSense will let you know that there is a syntax error there. So actually, like that was kind of that's what happened from a compiler's perspective. I'd rather actually go jump into the code for you guys because I know we're running out of time here. Actually, we already ran out of time. So let me just open a quick demo for you to explain how the asynchronous work. So this demo is very very simple. This application is super simple actually. As you can see here, that like we've got a 1, 2, 3, 4, 5 buttons. One is synchronous, one is using await with a sync, one is no await, but we're calling a synchronous method. This is a navigate page. This is a press me button. I mean, like these are all buttons, and just go to every button and let me show you what every button does. So that's the main page. We've got a method called a long running operation. Okay, that's just a long running operation, an operation that takes 7 seconds to execute. Okay, and we're using the debug the try line console to show that we're the value of the thread, the current thread that executing this this method. So we're just getting that so that we identify that, and once we're making a return of 42, whatever this number is, just to kind of flag that the operation is done. Okay, and then so this is asynchronous programming. Let's run actually on the emulator, and let's see how would it be like. So that's the application. Again, and yes, and the press me, this is a button with nothing to do. So if we just go to the press me code, press me. Actually, you won't find a code for it actually because it's not handled. Let me just pause that. This one is not handled, so there's no event for that button. Just a button, and I will just show you right now why we're doing that to it. Let me run again. So if I'm calling it sync, what's happening here? You'll see down here at the bottom. Let me make it easier for you guys. We're invoking a long. Okay, let me do it again. So I'll do it one more time. So when I press the call it async, okay, the debug write line that I wrote will tell me that I am invoking a long running operation synchronously on the thread number 1, and that code and this is and the thread. So that's the when I invoked it, and that's what the thread is running in the in the method, and this flags the end of the method, and so that's it. So when I press again, so questions? Am I getting questions? Okay, let me just. Oh, okay. Oh, okay. Sorry. Okay. Interesting. So, where it is? So let's run it again. So now, just like this is the application of me, okay? And now I'm pressing the press me. If you can see the red color here, that means that I'm clicking on it. But because I'm not handling it, it just shows the a UI of a red color. That's with a Windows Phone application. With any Windows Phone app, that just triggers that a user has clicked that button. But if I call it, press on the call it, and now I'm trying to press the press me. As you can see, I'm trying to press with my mouse, but nothing is responding. Why? Because the main UI thread was busy with the sleeping for 7 seconds for the thread and preventing me from using the application. So the whole application was hanged up. I cannot use any of my application for this one. Is that clear for you guys, or before moving to the? Did you know why the problem with that? Yeah, will the app hang? Yes, it hanged. JIP, very clear. Okay, perfect. I thought like because the fever I have, it's I'll find it hard to share things with you. Send the code as well. I shared the stuff as I think on the on the SkyDrive. Okay, let's see how things would work on the the other the other where am I? Wait a second. Main page. So what about if I click on the await and async? So going to this button of yeah, that's why I forgot to. So this is the so that's happened when I press the call async. I'm sorry guys. So that's happened when I press the call async. I asked to run this method. Sorry for that. Oh, sorry. Something was wrong. Yep. So when I pressed the call sync, I identified which thread that I was using, and then I ran the operation, and then I was and then and so I identified both threads, or the thread before I click, or once I click, and once I enter the task. Okay, so this is the asynchronous one, and that's why if we do this run again, sorry guys for that. Wow. You'll find that the main thread is 1, that's the one I'm using, and it will wait for the 7 seconds, and then that's the thread that executed the method that I have, which is the same thread, which is the number 1, which is found in this long running operation thread, and that's it, right? And then continuing, that's what you find when you call when you press the call sync click. And what about the call asynchronous, the asynchronous call? You do the same thing. You identify the UI thread that you're having. Okay, so we're identifying with the thread, the main UI thread that we're having, and then we're calling the long running operation. But this is another method, which is the asynchronous method. Here, where is it? Let me just right click, go to definition. It's up. Yep. And then it's an asynchronous of task, and it's a task of integer, and I'm running a task. I'm running the same method in a task, but now I'm moving this task, or moving this execution of this method in a different thread. Is that clear for you guys here in the code? Let me check. Is it clear from the code, or do you have any questions? Guys, if it's not clear, please let me know. It's okay if you don't get it. It's okay. Okay. So So private async, so that's what happens. So let's even add some breakpoints and to show you guys what's going to happen here and there. So what we should expect when we press that, when we press with the asynchronous and await, we should get a number here for the UI main UI thread, okay? And this number should be different from the number of or that thread should be the ID of this thread should be different from the ID of the thread executing the task that we want. And during this task or during what's happening, the UI should work fine. So if I'm pressing await async, so now this is the UI thread that is happening, and see I can press the press me button while it's invoking the 7 seconds. Yes, I'm just here. This is a breakpoint. As you can see, the current thread is 4, but I don't need to do any debugging here because just continue. It will show up at the down here, which is so that means that this method was, or this task was executed on the thread number 4, and what the main UI was thread number 1. And again, if you check, the UI was not was working fine. I can click press me. I can even navigate to another page, which is amazing, and still this code will be running in the background. See, this code was still running in the background, although I left the page. This is very important I remember I added this part of the code because I got asked that question: what if I navigate from the page? Will I lose that code or not? So this is very important for you guys to know as well. Okay. The last button we're having is okay. Last button we're having is the no await async. And if you are calling a synchronous method, and you don't have to put await as long as it's you don't need to know the value. I mean, you're not like, for here we're getting this value and assigning that value to a return value, right? But what if you want to do some sort of a background operation that will save something or whatever, and you don't need you don't need to assign that to a value. You can just run this operation in the background, and that's it. So you don't need to add the async and the await modifiers. So now if we do that the same, but it will act the same way, but not with the async and await. So no await and async, thread pool, can navigate. You can just go back and do whatever you can do, and then again, the other thread was number 4, and then should now get and there is no return value as we said, so you just did some sort of an analysis in the background or what have you, but you don't need the value. I don't know, but you can do this thing in your applications as well. Is it clear, guys? I don't know. I mean, like that's kind of the difference between asynchronous and synchronous calls, and and how important it is for you guys to be using that. Questions? Because we're like 15 minutes beyond time, so all clear, all good.